Okay, so here we are. You should have finished, gone through that first page, and now we are on the second page of the 3-page weighing in packet, and this is part 4 T-charts, aka dimensional analysis. What is this really? Dimensional analysis is a systematic way of converting. So let's get that definition down. It's a systematic way of converting units. And not only are you going to use this in this class, you're going to use it when you take physics your senior year. It's going to pop up a lot. We are going to look at it in the context of chemistry. So if you look down here, how do we use it? There are 6 steps that will get us through this process. And thankfully, it's not really mathy in any way, only up towards the very end. So how do we use this? Let's look at the question, and we'll discover this process in the context of this question that we have here. What is the mass of 4.56 moles of water molecules? So in order to figure this out, we need to remember something, and this is going to be a little different depending on how far you got in the rice and bean measuring exercise. One thing that we need to know is that the mass of 1 mole of something on the periodic table is going to be the molar mass. And this is going to come in handy. But let's look at this in the context of our problem. So how do we systematically figure out the answer? Step 1, this is great, it doesn't even involve any math. Step 1 is you draw a T. And I call this a T-chart conversion because it literally looks like you're doing this on kind of a funky looking T. So our T, it's like a really short and fat lowercase t. So that's the first part, easy peasy. Step 2 is we take the number in the problem and we put it right up here. So let's take it back to the question. What is the mass of 4.56 moles of water molecules? The number that we're given in the problem is 4.56 moles. We are going to write that right up here. This is the number that we start with. Step 3, we take the unit that's in that first number and we write it in the bottom right. So we just basically copy. It's moles up here in the upper left. So we are going to write moles down here. Step 4, again, we haven't even gotten to any math yet, so I don't want you to stress out. It's about getting everything in the right place in this little T-chart. Okay, so we've written there our unit of moles because that's the unit that was written up here. Step 4 is we're going to write the unit that we're going to. What is the problem asking us to find? And that's going to go in the upper right-hand corner. So again, let's go back to the problem. What is the mass of 4.56 moles of water molecules? The question is asking us to find mass. Since this is science class, we always measure mass in grams. And so we're going to write that unit up here in the upper right-hand corner. All right, easy peasy so far. Again, no math yet. It's just getting everything in the correct spot. So for number 5, step 5, this is where people tend to get themselves kind of turned around. Step number 5 is we fill in the missing numbers. We fill in the missing numbers, and here's what I mean. We have 2 spots over in our T-chart that still don't have numbers in front of them, moles or grams. The little trick I'll tell you is that we'll always be thinking about 1 mole. The number in front of mole will always be a 1. So that's easy. That will always, always, always be the same. The question is, what does 1 mole equal? and that's what is going to go in the top. Now, you'll need your periodic tables. I want you to think about, we're talking about water. So the formula for water is H2O. Take a moment and pause the video, figure out the molar mass of water. You need 2 hydrogens and 1 oxygen. Take a second, pause, figure that out, and then come back. Okay, hopefully when you crunch those numbers, you found that 1 mole of water weighs 18.016 grams. Your answer might be slightly different if you use a different periodic table, but you should get 18 point something. I'm going to take that number and put it up in the one spot where I don't have a number yet. Now, we filled everything in. Like I said, we haven't even done any math yet. Really, the only question is just getting all the numbers in the correct spot. So, our final step in this whole process is step 6. And I like to say you multiply across, and divide under. So what does that mean? Let's look back up in the context of the problem. Any numbers that are here on the top, here we have 4.56 and 18.016, we are going to multiply those numbers together. We multiply across. Any numbers that are underneath, we are going to divide. In this case, we're dividing by 1, so it won't change anything, but that is what it means to multiply across and divide under. So to figure this out, we're going to take 4.56 and multiply it by 18.016, and I get my answer of 82.15296. So I've shown my work. What's the final part? I put a unit on my answer of grams. So from here on out, anytime when I talk about showing your work, this is this process that I want to see. You set up your T-chart, plug in the numbers, and then get your final answer. And so, again, in the future when I say show your work, this is what I'm going to be talking about. Okay, let's try it on your own, show all the steps. If you want, you can pause this and give it a shot. Or if you'd like, you can just kind of follow along with me on your own. Okay, I'm going to try this problem down here in the context of all of our 6 steps to success. Step number 1, draw a T. So here we go. Step number 2, I take the number in the problem. Here we are. And I write it in the upper left-hand corner. So I copy it, 6.3 times 10 to the 25th atoms. My next step, step 3, I write the unit of the problem down. I copy it down in the bottom right. My next step, step 4, write the unit that we're going to in the upper right. What's the unit that we're going to? The question is asking me to find moles. So I'm going to put moles up there. All right, again, no math yet. We're just plugging things in the right spot. So step 5, fill in the missing numbers. I mentioned up here, it's always going to be 1 mole. Always, always, always. There will always be a 1 in front of the mole. The question now is what goes on the bottom? How many atoms are in a mole? How many of anything is in a mole? 6.02 times 10 to the 23rd. All right, so step 6, multiply across and divide under. So we're going to multiply 6.3 times 10 to the 25th. We're going to multiply it by 1, which doesn't change anything, and then divide it by 6.02 times 10 to the 23rd. And we get 104.651, and then what's my unit? Moles. And here's my answer. So remember that In addition to just teaching you this process, I am interested in the chemistry that you use to solve these type of problems, but I really am teaching you this problem solving method. So if you're looking at these going, oh, I could figure it out in my head, or I could do it a different way and still get the right answer, at this point, I really, really want to see you do this type of problem in this way. So just keep that in mind here as we go on. All right, bop over to the next page. We are going to be looking at conversions that use molar mass, which is those numbers that you can get off the periodic table that we used to also call the atomic mass. And this is a little rhyme that's going to help you. If the question involves mass, you'll need the chemical formula to pass. And as we do these problems, you'll see, oh, do I use the number from the periodic table? Do I use 6.02 times 10 to the 23rd? The answer to that is if there is mass involved. If grams or anything show up in the problem, know that you'll need the chemical formula and the periodic table. Okay, so let's check this one out. Let's look at our example here. A friend offers you 50 moles of sodium metal. In order to figure out what sort of vehicle you're going to use to pick up the sodium metal, you need to figure out the mass of 50 moles of sodium metal. Okay, so to solve this problem, I'm going to be bopping back and forth between our 6-step sheet, but I want you to, you can just flip back and forth or just follow along. Okay, so our first step, draw a T, step number 1. We're going to draw a T. Step number 2. We take the number in the problem and we write it in the upper left-hand corner. What is the number in our problem? The number in our problem is 50 moles. Step number 3, we take the unit that was written and we copy it down in the bottom right-hand corner. In the upper right-hand corner goes the unit that we're going to. So again, this question is asking for mass. Mass we measure in grams. All right, so that was, at this point we've gone through step 4. Now we're on to step 5. We fill in the missing numbers. What number always goes in front of the word mole? The number 1. Now, the question is here, what number goes in this blank right here? You have 2 choices. One of them is right, one of them is wrong. We know that we could use either 6.02 times 10 to the 23rd, or we could use the number off of the periodic table. The key to the answer is this little rhyme up here. If the question involves mass, you'll need the chemical formula to pass. So in this case, our question is asking for mass, which means we're going to need to look on the periodic table. So take a second, find sodium. You can pause the video if you want. Otherwise, you can just rock and roll with me here. 22.99 grams for 50 times 22.99 as we multiply across. Divide under, and our final answer is 1,149.5 grams. Remember, I always stick a unit on my final answer. Okay, we have one more. I want you to try it on your own and then pause the video, then come back, try it on your own. Okay, this is going to be the last one that we're going to do together, and that is another conversion. So we're mixing up a batch of nitrogen triiodide, and you end up with 634.5 grams. How many moles is this? So let's go through our steps. Step 1. Step 2, I write my number from the problem. Step 3, I take the unit that I wrote up here, and I write it again down here. I take the unit that I'm going to, what is the problem asking me to find, and I put it up here. Okay, so that has gotten us all the way through to step 4 in our process. Now we're on to step 5, filling in the numbers on the right. So in front of moles always goes the number 1. And then we need to figure out what number goes here. Is it going to be 6.02 times 10 to the 23rd, or is it going to be the molar mass of nitrogen triiodide. In this case, because our question is involving mass, we're talking about grams, we're going to need to look on the periodic table. So if you look on the periodic table, you find nitrogen has a molar mass of 14, and iodine has a mass of 126.9. But remember, because I have 3 iodines, I'm going to have to add those 3 times. So to figure out the molar mass, I'm going to take 14 and add it to 126.9 times 3, because there are 3 iodines. And I get for that answer 394.71. That number is going to go right under there. So now that you have your t-chart set up, you plug and chug through 364.5 divided by 394.71. And we get for our answer 1.6075. And the number keeps going, but we'll stop there for now. Put a unit on my final answer. And there you go. Okay, so at this point, you've gone as far with these kinds of problems that you need to do. If you'd like, you can keep going with this lecture. We're going to be going over something called significant figures, or if you need a break, you can take a break. But at the very least, for class on Wednesday, my expectation is that you get to this point where you've taken notes on what a t-chart is. You have done the 2 sample problems, both A and B, that involve going from grams to moles and back again. All right, if you're sticking with us, and again, it's one of those things you'll all need to listen to this lecture eventually, but it's just, if you'd rather take a break, that's fine. But keeping going with significant figures. A significant figure is basically, this is our rounding rules for science class. Because now you've been getting all these big old long numbers that spit out of your calculator, and how do you know when to cut that number off? So a significant figure is what we use to talk about measurements in science class. A significant figure is a confident measurement. A confident measurement. And what I mean by that is that very often, like if somebody asks you how tall you are, you say, like, I'm 5'8.5". Well, I'm really sure about the 5. I'm really sure about the 8. I'm kind of sure about the half, but maybe it's not exactly half. I would not consider that half to be significant because I'm not confident in what that number is. The 5, though, and the 8, I am very confident about, so I could say that those are significant figures. Now, the next question, why is this different than math class? Is because in science, we are taking human-based measurements. We're taking human-based measurements. And because of that, they're not perfect. You know I love you to pieces, but your measurements are not perfect simply because you're a human being. It's impossible for us to take perfect measurements. Now in math class, you don't have to worry about this because we assume that in math class you are working with perfect numbers. Okay, so how do we figure out whether or not a number is significant? This map here of the United States will help us. Okay, so here we are, the US of A. We'll even draw a little eagle. That's very patriotic. And again, your eagle will not be as good as my eagle, so I don't want you to worry about it. Don't stress out. And he needs another wing. Okay, so here we are. This map is going to help us figure out what numbers are significant figures or not. And the geography of the US is going to help us out. I want you to think about the 2 coasts of the United States. Starting with this coast over here on the left. What is the name of the ocean that we have on this side? This is the Pacific Ocean. What's the name of the ocean on this side? The Atlantic Ocean. And this is actually going to help us out because we are going to use the P and the A to help us figure out when a number is significant or not. Let's start with the Pacific Ocean. We think about the Pacific Ocean when a decimal point is present. See, they're all P words. That's how you can remember it. We think about the Pacific Ocean when a decimal point is present. We think about the Atlantic Ocean when a decimal point is absent. So think Atlantic, point is absent, Pacific, point is present. All right, bopping forward. Let's start with the Pacific examples. I'm just going to throw out a couple of different numbers. Let's start with kind of an easy one, like 15.06. Here's how you figure out whether or not all of these numbers are significant. I want you to imagine like this number is kind of sitting there off the coast of California and you are out over in the Pacific Ocean. Here you are. And you are going to start heading in towards land. Okay, once you hit that number, you start counting at the first non-zero number and you count all the way to the end. So here I am, I hit the 1, that's not a 0, and we start counting all the way to the end of the number. This number has 4 significant figures. I'm going to abbreviate that SF. Okay, let's think of a different number, maybe a really small number. 0.0013. Here you are, you're out in the Pacific Ocean. You start heading in towards that number. You are going to start counting at the first non-zero number, but we're going to skip that number and that number and that number because they're all zeros. We start counting at the 1 because that is a non-zero number. 2 significant figures. Okay, I'm going to do one more. Here we have 8,000.00. This is a really accurate measurement. You're going to start out in the Pacific Ocean, start heading in, start counting at the first non-zero number, and you count all the way to the end. Each one of these numbers that's underlined is significant. So we say that this number has 6 significant figures. Putting 2 zeros after the decimal point like this indicates that you're being really, really accurate. Okay, let's bop over here to the Atlantic. In this case, the decimal point is absent. So we're going to do some numbers that do not have decimal points. Let's instead think about 8,000. We're going to tell the same kind of story, only this time you're out in the Atlantic Ocean. And you start heading in towards land. Start counting at the first non-zero number. So we skip this, skip it, boom. The first non-zero number, and we count to the end of the number. So this number has 1 significant figure. Now the difference between this 8,000 here and this 8,000 down here is the fact that one of them has a decimal point with 2 numbers after it. The 8,000 point, oops, I hit the down arrow, don't panic. This 8,000 has 2 zeros, which means this is a really, really accurate number. They've measured out all the way here. When you have a number like this could be 8,000, it could be like 7,986 and they rounded up. Maybe it's 8,011.2 and they rounded down. We don't know how accurate this number is, so we say it has 1 significant figure. Let's do another one here. 18,001. Let's tell the same story. You're out in the ocean. You start coming in towards land. You start counting at the first non-zero number. Oh, there it is. And you count all the way to the end of the number. This number has 5 significant figures. Okay, we'll do one more. How about 10? Start out in the ocean, zoom in towards land, and there you are. 1 significant figure. Take a second, pause the video, try the examples down here on the bottom, and then we'll regroup. Okay, this first one has 1 sig fig, 5 sig figs, 6, 6, 4, and 3. Okay, final page. How to use significant figures and T-charts. Okay, the rule is When you're given a T-chart conversion, and that's what we've been practicing. I'm going to flip pages here for a second. What we've been practicing up here, things like these with T-chart problems, how do we know when to round, how the Sig Fig thing works? Here's what you do. You look at the number in the problem. So, for example, I'm going to use example B here. Looked at the number in the problem. The number that we were given in the problem is 634.5. So you look at that number, you count the sig figs in that number. In this case, there's a decimal point is present, so we imagine that we're out in the Pacific Ocean. Bop in towards land, we have 1, 2, 3, 4 significant figures. That number equals the number of sig figs in our answer. So I'm going to go back to that same problem. It has 1.6075. Now this is the number that my calculator spit out at me, but I haven't rounded it correctly yet. So let's take a look at it. We know that we can have 4 sig figs in this final answer. How many do we have right now? Okay, a decimal point is present, so we start out in the Pacific Ocean. Zooming in, we start counting. 1, 2, 3, 4, 5. We have 5 sig figs in this answer, which means we're going to have to round. So the rounding rules are similar to what you would think of like in a math class. So here's how it works. We know we can keep 4. We're going to keep the 1. That decimal point stays where it is. We keep the 6. We keep the 0. And we need to keep one more digit, but we have a problem though, because it's a 7 and the number after it is a 5. And so those are rules that you would use normally like in any math class, where if it's greater than a 4, you round up. If it's 4 or less, you round down. So if this 5 is greater than 4, so that means that we're going to round our 7 up to an 8. And I think our unit should be moles. So this answer is our correct finalized answer with the appropriate number of significant figures. Okay, with that, that is as far as you need to get on this lecture. For the rest of the problems where it says practice problems below, we are going to be doing these all in class.